in listen-only mode.
If you are looking at SolidWorks or are currently using it, some recent media coverage indicating a new product is coming may raise concerns with what will happen to SolidWorks and any data you have created. If you chose to adopt SolidWorks, will that product eventually be shadowed by their next-gen system? Or if you're already using SolidWorks, will you have to someday convert your data for use in the next-gen system? It's anyone's guess. But after the strong announcements a few years ago showing SolidWorks on the V6 platform, you have to wonder, are your designs truly future-proof? Hi, I'm Yvonne Wiedemann of CamLogic, and I'd like to spend an hour or so showing you a way to protect your investment in 3D while getting a boost in productivity at the same time. First, I'd like to recognize Coach Yachts in France for supplying an image of one of their products, a luxury yacht. This luxury yacht was completely designed in Solid Edge, from the hull to the internal systems and even the furniture. Let's start by familiarizing everyone with CamLogic. CamLogic has been in the CAD, CAM, CAE space for over 35 years. The company was established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from manufacturing back to the conception of the idea or design. Because we started towards the end of the process and worked our way to the beginning, CamLogic has a fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. CamLogic employs the three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Romer and Creaform for 3D scanning for inspection and quality. Now that you've heard a bit about CamLogic, let's take a look at some of the changes taking place in the marketplace and how it may affect your future. If you have not looked at the SolidWorks news group, I'll take a minute to bring you up to speed on some recent SolidWorks posts. After the former CEO, Jeff Ray, announced how SolidWorks will move to Dassault's own CATIA V6 platform, customers and industry went on a rampage, worrying about the future of SolidWorks. Not soon after, SolidWorks softened their approach, where Matt West indicated, SolidWorks will not change and be developed in parallel to a new conceptual next-gen system, meaning SolidWorks will continue to be based on Siemens Parasolid modeling engine. Followed by another comment that SolidWorks will deliver a next-gen system with a new price strategy and an optimal transition, meaning a new system on a new platform. More recently, the new CEO told industry media that a new product coming in May 2013 will be complementary to SolidWorks and targeted to conceptual mechanical design needs. This initial botched announcement and an attempted recovery announcing now 2 systems raises questions on the future of data created in SolidWorks. What will the SolidWorks product portfolio look like? How many applications will you need to buy? And how will your data be translated between different systems? If you want to future-proof your design data, you must look at a few key factors. 3D CAD systems become successful through continual investment based on customer and market needs. The more investment is made, the more productive its users will be. Over the years, many CAD vendors have attempted to integrate different technologies, and users are left figuring out what systems to use. The ultimate CAD is a single system on a standard platform. No matter what the industry is, leading companies strive to have the latest in technology so that they can be more competitive. For example, what if the company making the washing machines on the left were never upgraded their design technology or manufacturing process? They would have been left behind as their competitors used more advanced tools to create the sleek, efficient design on the right. Advancements in technology are driven by both the supplier and the consumer. Engineers push CAD companies to deliver needed capabilities, and CAD companies must listen and look for ways to provide better design tools so engineers can create more innovative products. Without customer feedback and the willingness to invest, designers may not have adequate design tools and their products will suffer. Let's look at some statistics on how many innovations CAD companies deliver to the market. Taking from public sources, one competitor, SolidWorks generally delivers a few hundred enhancements per version and has a pretty consistent delivery rate over the years. In contrast, Edge has been delivering several times as many delivered requests. Just recently, Edge ST3 advertised delivering over 1,300 new capabilities that were requested by designers, just like you. So what can we learn from this trend? Flat line trends indicate low investment or an alternative investment. As SolidWorks has announced, they will soon deliver a new product. It's possible that's where the development dollars are going. It's common practice that CAD companies invest revenues from customer maintenance contracts back into delivering their requests. This trend and lack of delivered enhancements should raise concern. On the other hand, the superior number of delivered requests by the development team at Edge indicates customers are getting the latest in design tools. Here are some of the new capabilities Edge has introduced over the years. So starting in 1996, we were the first to announce a 3D Windows-based CAD system. In 97, first to offer drag and drop sheet metal design with flat pattern creation. 98, first mainstream system to interoperate with Enterprise, which would be NX. 99, first to offer a complete tubing design systems. 2001, first system to offer a Microsoft SharePoint data management solution. 2003, first system to offer order-free surface design. And starting in 2008, a multi-year development project brought to market Synchronous Technology for accelerated design, faster revisions, and better reuse. This new approach to design is completely unique, offering a better alternative to traditional 3D CAD. As you look at your own design needs, are your enhancement requests being delivered? This is something you as a design community need to take seriously. Think about the responsiveness you have experienced with your current CAD system. And think about what you feel the future will entail if the resources are split between the current system and a developing new system. Caprock, a contract manufacturer, also had concerns about the kernel swap. Joshua Walls, a senior project engineer at Caprock Manufacturing, claims that using SolidWorks, if you discover a mistake made earlier, in many cases, just forget it. You might as well start over. They decided to move to Edge, and they were able to cut design time by 5 times. All CAD systems have core tools for computing sketch layouts, 3D geometry construction, part placement, and drawing view creation. Different core components are not the same, and they don't give the same results. For example, take the modeling example on the left. In this simple 4-edge blending case, there is a certain type of patch at the blend intersection. These are the results from Parasolid, the kernel used by most CAD, CAM, and CAE applications, and the kernel that is used by both SolidEdge and SolidWorks. Shown on the right are results from a different modeling kernel. Notice the single face patch at the intersection of the blends. Now both of these results are valid answers, but the point is that they are different. Moving data from one system to another requires that the receiving system be able to read the differences in geometry. Otherwise, math properties can be wrong, and downstream applications such as tooling can become invalid. No matter what the industry, this is why companies try to standardize on a single platform. They then try to eliminate impacts from any system differences. Here's the typical life cycle of software. Version 1 comes out. People get a productivity boost and then hit a ceiling. Version 2 comes out, filling the gaps from version 1. Users get more of a boost and then hit another ceiling. The cycle of upgrades begins with planned end of life. When companies realize their technology has reached a limit, they have two options. The first is to provide continuous innovation by integrating new technology into their existing product. The evolution of Microsoft Windows operating system is a good example of this. They continue to make their platform better by continually improving over the last. And an alternative approach is to abandon the current product and focus on a new technology. Initially, the new release will not have all the capabilities, but tends to show promise in providing their users a better solution in the long run. A good example is how Microsoft saw the limitations of DOS and then began development on Windows. Windows was more complicated, but the compromise or the promise of multitasking was too good to pass up. SolidEdge found a way to better design and integrated that approach into the current system. This gives customers the ability to take advantage of these advancements when convenient and with minimal process change. SolidWorks has indicated a next-gen system is coming. So does this mean out with the old and in with the new? The question becomes, what are the impacts from either approach? When new technology is delivered in the same system, users have less to learn with less process change and quickly get a competitive advantage. This approach is more difficult to develop, but provides customers the best possible experience. With multiple offerings, customers must install, learn, and address incompatibilities. The gap in capability between current and new capabilities is where inefficiencies happen. This approach tends to be the easy way out for vendors and places the implementation burden on the end user. When the developers for SolidEdge saw limitations with current design methods that inhibited designers' ability to create, edit, and work with imported data, a shift in technology was needed. They invented a new design paradigm called Synchronous Technology. And as opposed to inventing a new system to deliver this technology, the designers found it was better for customers to have the ability to leverage synchronous technology in a single system. The results gave designers a system for accelerated design, faster revisions, The results gave the designers a system for accelerated design, faster revisions, and better imported reuse. We'll talk more about synchronous technology later. But before we go on, Most companies have had to migrate from one system to another at some point. Thinking back, how did your company prepare for those transitions? Are you preparing for those transitions again? These are all things that we need to think about as CAD systems make major design changes. Halina, a medical device company, was one of the first companies to purchase SolidWorks. They were a long-time customer and doing just fine, but they were concerned with the kernel change. Billy Oliver, a design engineer at Halina Laboratories, wasn't willing to wait around. So they took that concern as an opportunity to look for ways to design better, and they found Solid Edge. They moved to Solid Edge and were able to preserve 100% of their data. So, taking a look at the screen, can these devices be used to communicate? Of course. But which one will make you more productive? A rotary phone or a mobile device? It's no news that innovations like real-time video chat or content searching give us new levels of communication. If you were presented with both options today, which one would you choose? Choosing design technology isn't much different. You look at the best option that meets your requirements. The history-based technology approach used by most 3D CAD systems is proven to work. Despite the challenges such as design pre-planning, slow updates, or inability to reuse imported data, millions use it each day to develop new products. And your ability to innovate is no different than your competitors. As we mentioned earlier, the developers at Solid Edge realized this and invented Synchronous Technology. It removes the barriers to better design, giving you a competitive advantage. Let's take a minute to see how Synchronous Technology works. History-based systems capture your operations and track them chronologically. When a change is needed, you find that operation and modify it as necessary. Subsequent features, if created correctly, rebuild to accommodate the change. Because of this rigid approach, features and their parameters can provide highly automated design modifications. The downside is history. Getting reliable updates requires a tremendous amount of pre-planning, and once a design is planned out, models become inflexible to change. Performance suffers from a model regeneration, often recomputing unrelated features. Competing technology, or history-free systems, don't have a concept of features and don't track creation order. Since created geometry isn't dependent on each other, edits can be made with blazing fast performance. But building intelligent models is nearly impossible. For example, building a relationship so an edit to one area can automatically update other parts of a model may be impossible to define. Synchronous technology incorporates the best of both worlds. Highly automated features with dimensions and unbounded flexibility and nearly instant performance. You can create models with features such as holes, rounds, ribs, but operations are not dependent on each other. So you have tremendous flexibility in defining or altering design intent when needed. 3D driving dimensions can be added to control distance between, or simply draw a fence around a model and sketch it into shape. A unique concept called live rules finds and maintains geometric intent. As you look at your own design process or business goals, what would help you service your customers better or conquer the competition? Do you currently have the biggest competitive advantage? If you are concerned about SolidWorks' future and need to future-proof your designs, it's time to take a look at Solid Edge with Synchronous Technology. Thanks to another Solid Edge customer, Starrett Corporation, for supplying this image of one of their products designed completely in Solid Edge. So what advantage does Synchronous Technology bring to your designers? It's a way for you to design better. Simply put, Synchronous Technology offers accelerated design, faster revisions, better reuse, and it's easier to learn. Let's take a closer look at how we can help you design products faster. Our unique feature-based history-free approach eliminates design pre-planning. With our unique way to design using both 2D and 3D, you will get full digital prototyping capabilities. With automatic intent capture within Synchronous Technology, you can quickly redesign and refine on the fly. All this gives designers a way to get products to market up to 25% faster. Now let's take a closer look at how we can help you revise and refine your designs faster. Without rigid design and modeling constraints, you can make changes as you need and not how the model was created. Our unique live rules let you make changes that preserve intent without having to redefine it. And the most valuable part is with Synchronous Technology, models don't need to be regenerated, so you can expect blazing fast performance. What does all of this mean to you and your customers? Get design revisions in minutes instead of hours. Now let's take a closer look at how we can help you reuse more imported 2D and 3D data. You can make precise changes by adding 3D driving dimensions directly to completed or to imported models. Push, pull, and rotate geometry with the steering wheel and some key features will be recognized, allowing parameter type modifications. And my personal favorite is our unique live rules. Automatically finds design intent from the 3D model, even the rules that were lost during translations. What does all this mean to your design team? Make revisions in-house and eliminate change fees. Let's take a look at a very successful Solid Edge customer, Lutnager & Fry. This company is a leader in electric bakery equipment and was challenged with trying to standardize models for improved reuse that would ultimately shorten times to market. After adopting Solid Edge with Synchronous Technology, their designers reported a huge time savings. What used to take 3 weeks now takes only 1 day to complete. Those are huge savings with tremendous positive impacts to their customer. Imagine the cost savings with each project. Product quality has also increased as their engineers report fewer part interferences. Now let's take a break from my talking and see Solid Edge with Synchronous Technology in action. We'll see a few quick demos, starting with how to design with without pre-planning. Then we'll see blazing fast revisions, followed with how you can edit imported data, and finally concluding with how easy Solid Edge is to adopt. I'm going to hand this over to John. Enjoy the demo.
Solid Edge ST3 has an integrated design environment that allows you to apply ordered features to synchronous models. Synchronous modeling provides a perfect foundation for accelerated design, faster edits, handling imported data, and allows ordered features for process-type parts. Synchronous modeling helps you create 3D parts quicker because design pre-planning is no longer needed. We'll begin this engine cover by drawing and dragging sketches into 3D features. Sketches can be created in 3D space or directly on the 3D model. When selected, closed sketch regions display a handle, and a quick grab and go turns them into 3D features. Pulling regions adds geometry, and pushing them removes material. With fewer commands to learn, new users adopt Solid Edge faster, and experienced users design more efficiently. Working top-down, adjacent parts can be used as a guide, ensuring parts fit together as you design. Fast, flexible edits make designing in Solid Edge a fluid experience. Watch as we easily add height to the guard. Geometry creation and manipulation is simple. Select a 2D region or a 3D element and use the drag handles to edit the part to shape. Dimensions appear or can be added at any time for precise change. While Synchronous forms the design foundation, Solid Edge ST3 allows adding ordered features for process-type steps such as castings with its machined counterpart or documenting the cutting steps after a weld operation. Here, we'll add a stylized shape to the top using Solid Edge's Rapid Glue surface tools to increase the appeal of the final design. Adding traditional treatment features such as rounds and a thin wall are quick and simple. As you design, features are collected in the Pathfinder but are not dependent on the creation order. You can make edits to any feature, and unaffected operations are not regenerated. Imagine editing the first operation as fast as the last. Creating models with synchronous features and having the ability to add ordered steps greatly extends your capabilities. You have the speed and flexibility when making precise edits, and any ordered operations documenting a process are maintained. With an integrated design environment, Solid Edge ST3 fulfills the vision of synchronous technology for accelerated design, faster, more flexible change, and more reuse with imported data. If you've used a traditional 3D CAD system, you're familiar with performance issues due to model regenerations. Let's look at a typical engineering change order scenario and see how much faster edits can be made using Solid Edge with Synchronous Technology. Most change orders begin with documenting a set of requirements. View and Markup in Solid Edge allows you to efficiently mark up assemblies, parts, and drawings, which can be emailed using a lightweight PCF file. Recipients of the file can view the changes in Express Review, a free viewer that can be downloaded today. You can package all types of documents such as requirements documents, spreadsheets, drawings, and even images. After reviewing the requirements in this engineering change order, it's time to make the edits. Before we show you just how fast Solid Edge with Synchronous Technology is, let's refresh your memory on what it takes to make changes in a traditional 3D CAD system. We'll start with this console cutout. Feature edits in a traditional CAD entail a delete and recreate process, so during any edit, the model rolls back, deleting all subsequent features. Only features built to accommodate future changes will update correctly. We got lucky here as this feature was constrained to keep the cutout in the correct position. This simple edit took over 15 seconds to make, but larger models can take much longer. We'll make similar edits to the frame and hanger clearance pockets. Once the edit is complete, all remaining features must regenerate, even operations that were not affected by the change. This rebuild process is a common source for model failures because subtle changes can cause severe and unexpected results. The behavior of this 20-year-old architecture is what most people consider the norm. Let's now make a more complex edit to the tank profile. Since this change wasn't something the designer planned for, the results will be unpredictable. Once the edit is complete, notice how many features failed. The original designer didn't build the model in anticipation of such a change, and this is a classic problem found with traditional CAD technology. During the regeneration process, subsequent features are bound to break. Imagine the number of steps required to fix all these features. Creating models flexible to changes in a history-based system takes a tremendous amount of pre-planning during the construction phase so that edits will give the correct results. As we see here, the model wasn't built to accommodate even the simplest changes, and if you did not originally create the part, you have to untangle someone else's mess before you start. Let's now see how SolidEdge with Synchronous Technology eliminates these issues. We'll make the same changes in SolidEdge so comparisons between the technologies can be seen. An initial difference is how models are edited directly. With this approach, changes are made directly to the geometry, so you can edit in the most convenient way. Simply drag a face or add 3D driving dimensions. Remember, the edits with traditional CAD took a while to recalculate and lots of additional time was required to fix failed features. But using SolidEdge with Synchronous Technology, these edits are done in just a few seconds. The edits you see here are happening in real time. When you need to make fast, reliable changes, there really is no better system than SolidEdge with Synchronous Technology, even with parts coming from other systems. SolidEdge ST3 lets you preserve design intent from imported 2D drawings to imported 3D models to improve data reuse. Let's start the process by reading a 3D part and associated 2D drawing from another system. SolidEdge's migration wizard ensures drawings look the same in SolidEdge as they did in the original system, including layers, line styles, color drawing scales, and more. Using the Create 3D command in SolidEdge ST3, manufacturing dimensions from the 2D drawing are automatically added to the imported 3D model. These manufacturing dimensions are key when making changes. The goal of the designer is to alter the dimensions directly and not indirect sketch dimensions used during the modeling process. Prior to Synchronous Technology, imported models had to be redesigned to allow edits, but with these new enhancements, designers can make the changes as defined in the 2D drawing. Once the process is complete, the 3D driving dimensions can be edited. Unlike feature dimensions that control parts of a model, designers can now control what really matters, such as distance between holes and overall size across multiple features. The ability to edit imported models with precise dimensional control is made possible only with Synchronous Technology. During edits, design intent lost in translation is found and maintained with live rules. This keeps designers from having to remodel imported parts even when simple edits are needed. A similar behavior is seen when the base plate thickness is adjusted. Other coplanar faces are maintained, keeping the designer from making two edits. You can add dimensions from other drawing views all at once or at any time, depending on design needs. Here, the dimensions from an auxiliary view will be transferred to 3D, ensuring the positions of holes along the angled face are kept using the dimensions defined in 2D. Even intent established in detail views can be transferred into 3D. Regardless of drawing view scale, dimensions can be moved from 2D to 3D and are ready for edits. Watch as a precise change is made. Finally, fully associative SolidEdge drawings can be easily generated and manufacturing dimensions can be retrieved, ensuring design intent is maintained throughout. This new capability within SolidEdge ST3 helps designers reuse more 3D data from customers and suppliers, which help reduce overall engineering costs. Learning 3D isn't always as easy as you thought, and nothing like the familiar concepts you used in 2D. SolidEdge with Synchronous Technology provides an innovative new way of modeling that lets you realize the advantages of 3D without completely changing your machine design process. Let's see how fast models can be created. Starting in the assembly of this garden utility vehicle, we'll model a new part that connects the transmission to the chassis. The interface promotes fast adoption to modeling. Notice how the menu ribbon lists sketch commands along with 3D modeling tools, while handy command tips help you learn as you go, reducing training costs. We'll turn tips off for now, but we'll see more learning tools as we go. While we know the locations of the fixed components, we don't have a clear picture of how to connect the support to the transmission and chassis, so we'll figure that out as we go. The transmission is in a fixed location, so we'll start here by using a 2D sketch that contains the basic design for the support. It's not complete, but enough to get started. Hiding the assembly for now will let us focus on part creation. When drawing elements, you can use other parts as a guide. guaranteeing fit and position, but for now we'll just place the mounting lugs in a convenient location and position them later. During drawing, notice how SolidEdge has several drawing aids to help you create 2D sketches. For example, special icons display when certain key points are located, and alignment lines help you draw perfect horizontal and vertical lines. We'll mirror the sketches to repeat the detail. Closed sketches become regions and display a grab-and-go handle, so a quick pull creates 3D features. We'll add some depth to the center of the body to clear the auxiliary power takeoff pulley belt and create the transmission mounting lugs. Sketches can be drawn directly on geometry with a full complement of tools to control both position and shape. Creating cutouts or extrusions using a traditional CAD system would require different commands and design planning, but with SolidEdge we were able to develop this complete model with no 3D commands. As we grab the region, watch how material can be added or removed with a simple push or pull. We'll remove some material to form the auxiliary power takeoff tunnel. How do you find commands in a new system? Watch how the Command Finder provides a handy cross-reference guide to common commands, eliminating hunting. Simply key in a command you are familiar with and SolidEdge will find the equivalent or similar command in SolidEdge, showing you where to find it and even starting the command for you, rounding off the corners in this case. SolidEdge lets you refine your designs easily during the creation process. Here, we'll start by tapering the sides of the bridge and adjusting its size. Watch how the sides remain tangent as we drag the face. Likewise, we can move the top face and the model updates. This flexibility comes in handy when adapting components in a machine for other uses. Notice how the lug remains concentric to the holes as we drag it around. Because edits aren't dependent on creation order, the lug could just as easily drive the hole, so your designs can be easily modified to accommodate just about any shape. This is live rules in action. Relationships can be toggled on or off to get different results. Here, we try out the options by toggling the symmetric option. A traditional CAD system can't make these modifications without redefining feature constraints. Let's display the rest of the assembly and position the lugs to match the transmission and chassis. The hole in the transmission case and mounting hole in this lug are easily aligned. Live Rules ensures the opposite lug also moves to the correct location. Geometry can be moved with precision, either relative to its current position or parametrically with 3D driving dimensions. A unique capability with 3D driving dimensions is directional control, so edits can be made regardless of feature creation order. These dimensions can be locked and driven by formulas or spreadsheets. We'll finish up the design by verifying that the mounting holes are in the correct location. Working in 3D lets us see an adjustment is needed. Because SolidEdge is free from model history, the part can be quickly dragged into position, no feature dependencies to resolve. The flange ends are easily refined, and because of symmetry, Live Rules makes this edit a single operation. Notice as we make these changes that we're interacting directly with the geometry, never running special commands. The fewer commands, the more productive the process will be. A key point with this technology is that the system keeps the model intact throughout the process. The correct edges stay blended, mounting holes remain concentric, and orthogonal faces are maintained. SolidEdge with Synchronous Technology gives you the promise of 3D today.
If you are looking at SolidWorks or are currently using it, you must ask yourself, will your maintenance dollars be put towards delivering your requests? Do you have a plan on how you will transition to a new system? Can you wait for a tool that may not give a competitive advantage? So what's the next steps? We think we have given you enough information to make an intelligent decision to start future-proofing your data today. If you are still not sure, how about attending a Get the Edge event and learn how to use SolidEdge? Or take a copy home and evaluate it free for 45 days. For those of you that are ready to purchase your seats of SolidEdge, those of you who would like to attend CamLogic's upcoming SolidEdge events, or those of you that would like to take advantage of the free 45-day trial, please contact us here at CamLogic. Again, my name is Yvonne Wiedemann. You can reach me at 248-931-5309 or via email at yvonnew@camlogic.com. Thank you for your time today, and I look forward to working with you and your SolidEdge investment. Now, let's get out and design better.